Every time you buy something online, you hand over your life, your name, your home address, your credit card, your purchase history, and all of it goes into a centralized database controlled by a company you are trusting not to get hacked, not to sell your data, and not to use it against you. Spoiler, they will do at least one of those three. Amazon knows what you buy, when you buy it, where you live, what you almost bought. eBay shares your address with every seller. Every marketplace breach that happens put millions of home addresses into the open. And the worst part is that there is no technical reason it has to work this way. What if you could buy physical goods, real things that need to be delivered to your front door, where your address is encrypted so that only the person delivering can read it, where your identity is mathematically unlinkable across different purchases, where the payment is escrowed in shielded coins that nobody can trace back to your wallet. That's exactly what dMarket built on Midnight, a third-party escrow marketplace for physical goods where privacy isn't a feature, it's an architecture. Let's tear it apart. Most marketplaces have two parties, buyer and seller. You pay, they ship. Simple, but it only works because a centralized platform sits in the middle, enforcing trust. Amazon guarantees your refund. eBay mediates disputes. PayPal holds the money. dMarket introduces a third party, the carrier, and that changes everything. Here's the model. Three participants, seller, carrier, and buyer. Each has different incentives. The seller wants to get paid. The carrier wants their delivery fee. The buyer wants the item. And nobody trusts anyone else. So the smart contract becomes the trust layer. Here's the math that makes it work. The buyer deposits price plus fee into the escrow. That's the item cost plus the carrier's delivery fee. Then the carrier also deposits price plus fee. The carrier puts up matching collateral, is key in the game. Now the contract holds 2 times the quantity of price plus fee. On successful delivery, the carrier gets price plus 2 times fee, that's their own deposit back, plus the delivery fee from the buyer's deposit, and the seller gets the price. The treasury goes to 0 and everyone's happy. But on a dispute, say the item never arrives or it gets damaged, the buyer gets refunded price plus 2 times the fee, and the carrier's price equivalent deposit gets burned. The carrier loses money. The seller resolves the dispute. This is the key insight. Because the carrier has collateral at risk, they are economically incentivized to actually deliver the items correctly. No centralized platform needed to enforce behavior. The escrow math does all this. Game theory enforced by code. Now let's talk about identity, because this is where dMarket gets genuinely clever. In a traditional marketplace, your account is your identity. One account, one purchase history, one profile that accumulates everything you've ever done. On blockchain marketplaces, your wallet address is your identity. And since every transaction is public, your entire purchase history is visible to anyone with a block explorer. dMarket solves this with obfuscated identifiers. Here's how they work. Every user's identity is computed by a function called computeUserID. It takes 4 inputs and feeds them into Midnight's persistent hash. Input 1. your public key. This ties the identity to your wallet. Input 2, your secret key. This comes from a secret key witness. It's a private nonce derived from your password that never leaves the CK circuit. Input 3, the instance salt, which is kernel self, the address of this specific contract deployment. And input 4, a domain prefix string. The domain prefix is where the magic happens. When you are acting as a seller, the prefix is dMarket seller ID. As a buyer, it's dMarket buyer ID. As a carrier, it's dMarket carrier ID. Same wallet, same secret, same contract, but different prefix, completely different hash outputs. And that means the same person gets a different identifier for each role. You can be a seller and a buyer on the same marketplace, and nobody, not other users, not observers, not even the contract itself, can tell it's the same person. The identities are cryptographically unlinkable. But it goes further. The instance salt means your seller ID on marketplace A is different from a seller ID on marketplace B. Cross-instance unlinkability. And the secret key from the witness means that even if someone knows your public key, they can't compute your marketplace IDs without knowing your password. External unlinkability. 4 inputs, 3 layers of unlinkability, and the resulting ID is disclosed, made public, because it needs to be used as a map key in the ledger, but disclosed after hashing. The hash is irreversible. The inputs stay private. When the contract needs to verify, is this caller actually the buyer for this offer? It recomputes the buyer ID from the caller's public key and secret, then compares it to the stored one. If they match, you are the buyer. If they don't, the transaction fails. Identity verification without identity exposure. Here's the problem that makes physical good marketplaces fundamentally different from digital ones. Someone has to know where you live. You can obfuscate identities all day long, but the package still needs to arrive at a physical address. dMarket solution: encrypt the delivery address so that only the selected carrier can read it, nobody else, not the seller, not other carriers, not the blockchain, not observers. Here's the flow. When a carrier registers on the marketplace, they publish an RSA public key. This key is stored disclosed in the ledger. Anyone can see it because anyone needs to be able to encrypt to it. Think of it like a mailbox slot. Everyone can drop a letter in, but only the mailbox owner has the key to open it. When a buyer purchases an item and selects a carrier, the purchase transaction triggers the encrypt witness. Inside the witness of chain in the CK prover, the buyer's plain text delivery address gets RSA encrypted using the selected carrier's public key. The ciphertext goes on chain as part of the purchase detail extract. The carrier, and only the carrier, can decrypt it using their RSA private key via the decrypt function on the API. Everyone else who reads the offer, it only sees encrypted gibberish. And here's the UX trick. The RSA key pair is deterministic. The user's password gets SHA-256 hashed into a secret key, and that same hash seeds a deterministic PRNG that generates a 1024-bit RSA key pair. Same password, same keys, every time, on any device. No key file management, no hardware wallet for the encryption layer. Just remember your password. The trade-off is real. Password strength equals security strength. For a hackathon demo, this is a smart UX choice. For production, you would want 2048-bit keys at minimum and a more robust key derivation function. But the pattern, encrypt inside the witness, store ciphertext on chain, decrypt off chain, that pattern is production ready architecture for any selective disclosure system. Okay, so we've got obfuscated identities and encrypted delivery. But what about the money? The whole escrow model depends on shielded coins that the contract can hold, validate, and distribute. dMarket implements this through a dedicated coin point compact module that manages the escrow treasury. Let's walk through each operation. First, minting. The mint coin circuit creates 10,000 dMarket specific tokens per call. Each coin is stamped with a domain separator, the string dMarket shielded coin, combined with the contract own address via token type, coin domain separator, and the kernel itself. This creates a unique color for the coin. Think of it like a currency code. These aren't generic tokens, they are dMarket tokens minted by this specific contract instance. Why does that matter? Because of the color check-in receive deposits. When everyone deposits coin into the escrow, the contract validates that the coin's color matches the expected token type. If you try to deposit coins from a different contract instance, a different marketplace, or some random tokens, it's gonna get rejected. This prevents cross-contract token spoofing. You can't counterfeit the market coins. After the color check passes, receiver deposit calls receive shielded to accept the coin, then merges it into the treasury using merge coin immediate. If the treasury is empty, it writes the coin directly. If it already holds coins from a previous deposit, it merges the new deposit into the existing treasury coin. One treasury coin represents the total escrow balance. On payout, send payments does a two-step distribution from the treasury. First send, transfer amount 1 to recipient 1. Second send, using the change from the first send, transfer amount 2 to recipient 2. If any change remains after both sends, it goes back to the treasury. If the treasury is empty, it resets. The treasury lifecycle across a full offer is clean. It starts at 0. Buyer deposits price plus fee. The treasury holds price plus fee. Then the carrier deposits price plus fee. The treasury holds 2 times the quantity of the price plus fee. On completion or dispute resolution, both sends execute and the treasury returns to 0. Perfect accounting, no funds trapped, no manual withdrawal needed.